Hello, Sanjay. How are you?
Fine, ma'am.
When is your test on aldehydes and ketones?
I'm not sure, ma'am. We have not come to this.
They
Just
have
in
not
electrochemistry.
announced. They haven't announced.
No, ma'am. No, ma'am.
What are you doing in school?
Electrochemistry, ma'am.
Hmm?
Electrochemistry, ma'am.
Electrochemistry. How are you, Sai Kalyan?
I'm fine.
At least when you say hello, for that time in the beginning of the class, you should switch on the camera and say hello, isn't it? From a behind the screen, it's not fair. How are you?
I'm
What
fine.
are you doing in school?
In school, Miss is taking biomolecules.
Oh, biomolecules. Oh, that is why you wanted to learn kinetics, because she skipped all aldehydes and ketones straight to biomolecules, or has she finished aldehydes, ketones?
No, miss. She didn't take aldehydes and ketones. Probably after this she will take.
Biomolecules and all, they are small topics actually, probably. I don't know why she finished in the beginning itself. But what is special, that biomolecules, in that the carbohydrates are also aldehydes and ketones only, isn't it? So if you learn the reactions of aldehydes and ketones, you are actually indirectly learning the reactions of carbohydrates also.
Yes.
Yeah. So who else? If nobody is coming, I will start the class. One more person seems to have come. Harini. Harini? No. Oh, Vaishnavi.
Namaste, ma'am.
Namaste. How are you? Vaishnavi, you should also switch on your camera and say namaste, not behind the screen.
Yes, ma'am. Namaste, ma'am.
Namaste. क्या हाल चाल है? How are you?
Yes, ma'am, I'm fine, ma'am.
What are you learning in school?
Ma'am, they are now doing solutions, ma'am.
Okay. So what did they finish aldehydes and ketones?
No, ma'am. After solution, they are deciding to do electrochemistry and
Electrochemistry you have already done, so we are ahead of your school, that means. Okay, so we are going to do aldehydes and ketones, and you are doing solutions. The solutions you have already done, so it must be useful for you.
yes,
Okay,
ma'am.
so now three of you are there. I will start the class because I can't wait for those who are late. So we are going to start with this class of compounds called aldehydes and ketones, right? This is the chapter which I always say that in case you are having very little time to revise organic chemistry and you have 4-5 chapters on organic chemistry and your time is limited, then one chapter, and you have time only to do one chapter, then always do aldehydes and ketones because it's the most important one. And lots of questions, they come from aldehydes and ketones. So why do we put aldehydes, ketones, and carboxylic acids together. So why do we put all of them together? Is because of something which they all have in common. Aldehydes, ketones, and carboxylic acids. What they have in common is a carbonyl group. Carbonyl group. Okay. What is a carbonyl group? Carbonyl group is C double bond O, carbon and double bond O. So this group, C double bond O group, it is known as the carbonyl group, right? So if you have the C double bond O group, so I will write the C double bond O group with here. Right. So I have my C double bond O group. I'm writing it 3-4 times and I'll make compounds out of it. Okay. So in this C double bond O group, first what I am doing is I am going to put a H on either side. H and H. Here also, here I am going to put a CH3 and H. And here I am going to put a CH3 and CH3. Okay. So all of them have the same group, C double bond O, C double bond O, C double bond O. What I have written, the first two, you compare the first two. In the first two, what do you find? It has this group in common. What is the group in common? It is CHO. What is the group in common here? It is CHO. So anything which has a CHO group present in it, it is known as an aldehyde. Or on the carbonyl group, if both free valencies have either hydrogen or one alkyl group and hydrogen, then they are called aldehydes. Then they are known as aldehydes. If you have both alkyl groups, right? If you have carbonyl group and both free valencies have a carbon chain or a alkyl group, then they become what? This one here, it becomes ketone. Okay. So both aldehydes and ketones, what do they have? They have C double bond O group in common. What is the difference in aldehydes? At least one of the free valency. This is known as a free valency. Here, this is a free valency and this is a free valency. So on this free valency, if I have at least one hydrogen, then it is an aldehyde. If none of them are hydrogen, then it is known as a ketone. So aldehydes and ketones. Now let us take this a little further. I also have several other compounds with this C double bond O group. So now I have C double bond O. What I taught you is that if I have both H, then on C double bond O, I can have one H and one R. Then it is an aldehyde. If on C double bond O, if I have both R, both alkyl groups, then it becomes a ketone. Now, if I have C double bond O and I have a free valency here, on one of them, if I put a OH, right, and I put a R here, right? So what group, what is the functional group here? It is COOH, and this is an acid. We call it a carboxylic acid. I could have a C double bond O group, and here I have R, and here I have, say, NH2. Then I call it a amide. I could have a C double bond O, and here I have a R, and here I can have a Cl. Then I call it acyl halide. Okay. These two, I could write some more. Here in one line, I will write one more. I have C double bond O here. Here I have OR, and here have R. Then what I get here is an ester, right? So all of them, they have one group in common. These are all carbonyl compounds. What do they have in common? They have a C double bond O in common. So they are all compounds which are known as carbonyl compounds. Okay, whenever you look at a compound, you find a C double bond O group there, you know it is a carbonyl compound. Now, if this carbonyl compound has one H, at least one H, then what do I call the carbonyl compound? It is an aldehyde. If I have here also one H, so it is aldehyde. Here both are, then it is ketone. So these are different types of aldehydes, ketones, and different types of compounds which come under this class of compounds which have carbonyl group. Okay, so all compounds which have carbonyl group, we are studying them together in this chapter: aldehydes, ketones, and carboxylic acids. The three which I have written here, they are known as acid derivatives, because they have to be obtained from acids. So in the beginning, first half of the chapter, we will learn about aldehydes and ketones. In the second part of the chapter, so this is the first part of the chapter, and this is the second part where we learn about carboxylic acids and its derivatives. In the first part, we will learn about aldehydes and ketones. Now, these aldehydes and ketones are very, very important compounds. We come across them in everyday life. Say, for example, you see, okay, so these are the common aldehydes. Okay, so common aldehydes, which are those common aldehydes? These aldehydes are many times compounds with strong smell and flavor, just like esters. So vanilla, you can see the vanilla ice cream that you have. This compound also contains a CHO group. It is present in certain types of beans. And if you take the extract of that beans, that makes a vanilla essence. And that essence is present in the vanilla ice cream. Most cakes that you eat, they contain vanilla flavor. Then you must have used this, you must be using this in, your mother must be using it in the kitchen. It is called cinnamon. In English, you call it cinnamon. I don't know what you call it in Tamil. Anyone knows the Tamil of cinnamon? In Malayalam, we call it patta. Anyone knows? This is how it looks like. This is a bark of a cinchona. It's a bark of a tree. So it is known as cinnamaldehyde. It is a very common ingredient that you put in garam masala, the masala that you use in kitchen, that contains cinnamaldehyde. Now this one is benzaldehyde. This structure is benzaldehyde. This is present in almonds. In Hindi, you call it badam. In English, you call it almonds. This is present in almonds. And it has a smell of, not, it generally is, it has a smell of bitter almonds. It's very characteristic smell it is. It is used in floor polishes. So when you go to the housewarming in a new house which has recently the floor has been polished, the typical smell that you get, that is of benzaldehyde. So aldehydes, this is also a CHO group. So these are the common aldehydes you come across. Then you have some some ketones like camphor, which you use in puja every other day. You use it in puja, camphor, right? Now camphor also has this carbonyl group. It is a type of a ketone. Then this mint, okay, peppermint that you must have tasted in some types of, you know, flavoring, some sweets, toffees that you use. That also contains this group. Okay. You use zira, you know, jeera rice or jeera, jeera cum that you use in yours at home. That is also that also contains this carbonyl group, right? Then this I'm not too sure, but this some flavored cheese, it also contains this the cheese that you have, it is also containing this heptanone. And then jasmine, it also has a smell because of this group, which is the carbonyl group. Then these are, you know, you must have heard of this word hormones. Sometimes, even though I don't know how many of you are biology students, but if you are, then you would have heard this word hormones. So hormone, O-N-E, it ends in on. So they are those compounds which contain a carbonyl group. So where is my carbonyl group? Here is my carbonyl group. Where is my carbonyl group? Here is my carbonyl group. So this is called testosterone, that is a male hormone. Progesterone, this is the hormone. Okay, this is also a hormone. So all the hormones also, they contain the carbonyl group. So it's an important group which is present in aldehydes and ketones. So now we need to learn the nomenclature of these aldehydes and ketones. We know the nomenclature. I'm going to just practice a few important ones. Nomenclature. Okay. We need to learn a few IUPAC names as well as a few common names. Common names are also very important because a few aldehydes are better known by their common names. So let us first look at aldehydes. Okay. So aldehydes are compounds which contain CHO group. Okay. So any compound which has CHO group, and if it has one CHO group, its general formula of this compound will be CnH2nO. Okay, CnH2nO. And the suffix here for the functional group, the suffix is Al, al. Okay, so let us learn first one. Which is the first one? It is HCHO. Okay, so one carbon atom only. So what will I call it? Meth and al, methanal. Common name of this compound is formaldehyde. Okay, formaldehyde. So any one of you who also has seen biology lab and specimens in the biology lab, they are, preserved in this formaldehyde. Formaldehyde dissolved in water. It is known as formalin. So, you know, in hospitals, in medical colleges, they preserve all their biological specimens in formalin. Formalin is a very important compound, commonly known as formaldehyde. And you can make a lot of polymers out of this formaldehyde. One common polymer that you make out of formaldehyde, it is known as bakelite. I'm telling you these things because now in our syllabus, polymerization is not there. So you may not come across this one. But bakelite is a very important polymer. Bakelite is used for making all your switches, switchboards. It's a bad conductor of electricity. So it's a polymer which is very useful in electrical appliances, especially for making switches, switchboards, switches, all those are often made of bakelite. So that is methanol or formaldehyde. Similarly, I will talk of one more in detail, that is CH3CHO. Okay, on CHO I have put. So this is known as eth and ethanol. Eth because there are two carbon atoms. Remember here what is special. The functional group also contains a carbon atom. So you have to count that carbon atom also in your longest chain. So it is ethanol. And the common name of this one is acetaldehyde. Acetaldehyde. Acetaldehyde is obtained from, reduction. We have learned acetaldehyde now in aldehydes and ketones. No, in alcohols. And I told you, you can, ethanol is obtained from ethanoic acid by reduction of ethanoic acid or by oxidation of ethanol. It comes, aldehydes come in the middle. So we can grow the chain. You can have 3 carbon atoms and make it. So this is CH3, CH2, CHO, 3 carbon atoms. So what will it become? Propanol. Now CHO will always be the first carbon atom. What I mean is, if I have this compound CH3, CH3 and CHO, what will I call it? Anyone? Sanjay?
Ma'am, 2-methyl propanol.
Yes, it will be 2-methyl propanol because you will choose that chain which includes the functional group like this. Right? So it will be 2-methyl propanol. You can't call it this 2. Sometimes children start calling it 2-propanol. No, because CHO group is always the first carbon atom. You don't have to write propan 1-al because it has to be, al is always on the first carbon. So this is a little thing that you have to remember. Now supposing I have CHO and CHO, 2 CHO. So what will I do now? There are 2 carbon atoms, so it is ethane, ethane and 2 CHO groups, so I'll call it ethane dial. The common name of this compound is glyoxal. If I have CHO, CH2, 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 CHO. Now can you name it? 2 CHO groups on the either side of the chain. Both will be included in the longest chain. So 1, 2, 3, 4, 5. So what will it be? Pentane dial. Okay, so remember to include both of them. However, if I have CHO, CH2, CH2, if I have 3 of them, CHO, CH2, CHO, right? I have 2 CHO groups on the chain. Then what will I do? Then the best way is not to include any one of them in the longest chain. So the longest chain is propane. 1, 2, 3, and to show that it is not, none of them are included in the longest chain, I call it carbaldehyde. When I make the suffix carbaldehyde, that means the carbon, which is the aldehyde, is not the part of my longest chain. So the chain is 3 carbon atoms, and on each of the 3 carbon atoms, there is one carbaldehyde group, that means CHO. Okay, so that is how you name the aldehydes. Now let us name the ketones. So nomenclature of ketones. Now in case of ketones, the suffix is, you write it as own. You write it as one, but you call it own. Okay. So supposing so minimum number of carbon atoms which a ketone can have is 3. So this is my smallest ketone, CH3, CO, CH3. So this is known as what? Prop, linked with a single bond, so propanone. And common name of this one is acetone. So these 3 common names you have to learn: acetaldehyde, formaldehyde, and acetone. These are common names of aldehydes and ketones which you need to know. So I can increase the number of carbon atoms in the chain, and then I can call it, now this is 5 carbon atoms, so pentanone. And since this can have different positions, so I have to show the position, so I'll call it 2-pentanone. Numbering will begin from that end, which is nearest to the CO. So pentanone. So like that, you can have CH3, C double bond O, CH2, C double bond O, CH3. So there are 2 carbonyl groups. So now I can call it 2,4-pentane dione. Okay, so that is how you can name 2 carbon atoms. So that is about ketones. Let me tell you a ketone which is COCH3. I can also write it as this C double bond O CH3. Okay, so this IUPAC name of this one is acetophenone. Acetophenone. Okay, so this is methyl phenyl ketone is a common name. Otherwise, it is known as acetophenone. Okay, so this is how you name several aldehydes and ketones. Now we will just take up a few different, 1 or 2 more I need to tell you. Supposing aldehyde and ketone group are present together. So supposing I have CH3, C double bond O and CHO. So this is what you should recall when you have 2 functional groups present together. Then what do? So when you have 2 functional groups present together, then you have to give priority to the aldehyde group, and this becomes the prefix. So what will I call it? This is propanal. This one. And second carbon atom is the keto group. Keto group, when it is a prefix, I call it oxo. So it becomes 2-oxopropanal. Okay, I should bring it closer. So 2-oxopropanal. Okay, so this group is known here as oxo. So if it is at the only group, functional group present, then it forms a suffix, becomes on. Otherwise, it is a prefix and it becomes 2-oxopropanal. I'm not yet taking up the nomenclature of acids. That we will do a little later. Now we are doing only aldehydes and ketones. So now we will take up Okay, so for the sake of revision, now let us try this. My camera is just not coming on right now. I don't know. It will be all right in some time. Okay, so let us try naming these compounds. Before that, let us try naming these compounds. Then we'll come back and revise. So because control. Okay. So how will I name this one? Somebody tell me. How will I name the first one?
Miss,
Yes, tell me.
3-oxopentanal.
3-oxopentanal. Very good. 3-oxopentanal. Right. Now, Sanjay, can you name the next one here? The second one? The second one, how will you name it? Sanjay, can you name it?
No, I'm not
Please.
sure.
How many carbon atoms in the longest chain?
5.
5. So what is it? Pentanone, right? Where is the C double bond O group? On the third carbon atom. So it is 3-pentanone. And there are 2 methyl groups on second and fourth carbon atom. So what will I call it?
So 2 methyl 3 pentanone.
Yeah, 2,4 dimethyl 3-pentanone or pentanthreone, both are correct. Now for cyclic compounds also, I did not give you any example. So for cyclic compounds here, let me show you one or two. So supposing I have the basic compound is this one, CHO on the benzene ring. So this one is known as benzaldehyde. Okay, so the basic compound here is known as benzaldehyde. Supposing there is a ring and a CHO group here, then I call it cyclohexane. Cyclohexane carbaldehyde. Okay, so the CHO group can be called carbaldehyde. So if I keep the CHO group outside the 6 carbon atoms, which are forming a ring, I call it cyclohexane carbaldehyde. So keep that in mind, and then we will name these few compounds which are given here. So the first one we have already done, that is formaldehyde. So the first one is methanal, and the common name is formaldehyde. The second one also we did just now, it is ethanal, and the common name is acetaldehyde. For few I will tell you, rest we can be. Now the next one, what will be the IUPAC name? Now just write the expanded structure of this. So you will realize that on the second carbon atom, you have a CH3 group. What is the structure of the third one? It is CH3, CH, CHO, and one CH3 here, right? It is a similar compound that we did just now. What? 2-methyl propanal. It is 2-methyl propanal. Okay, so it can be written the way I like this here. Now the next one, the fourth one. Who will tell me the fourth one? So first you name the
Miss,
compound. Yes, tell me.
3-methyl carbaldehyde.
Yeah, 3-methyl and carbaldehyde alone will tell you how many are in the ring also you have to say. So 3-methyl cyclohexane.
Cyclopentane.
Yeah, cyclohexane carbaldehyde. Got it? Then the next one. Next one is on the second carbon atom, you have a methoxy group. So you will call it 2-methoxy, 3 carbon atoms, so propanal. Next one is 1, 2, 3, 4, 5. Hariharan, tell me, what will be the name of this compound? 1, 2, 3, 4, 5. So what is it? It is 5 carbon atoms, so it is easy, isn't it? Hariharan, are you there? Hariharan? Hariharan, are you there? Can you hear me, Hariharan? So this is pentanal, right? Now the next one here, it is there is a,
Ma'am, is it
um,
prop to in carbaldehyde?
yeah, prop to a prop to enal. Okay, that is how you will write prop to enal. Now this 2 CHO groups on the benzene ring, it is
Ma'am,
benzene. What is it?
ma'am, when will we use like AL and carbaldehyde, ma'am?
Al we will use when the CHO group is included in the longest chain. This is my longest chain, right? So the if the carbon is included in the longest chain, so I have chosen to say propanal, so I have taken 1, 2, 3 carbon atoms in my longest chain. So al, then I suffix is al. But if I don't include any of them in my longest chain, like when I'm saying benzene, I'm not including either of the CHO in my longest chain. Benzene means 6 carbon atoms together. So what will I call it? Benzene and then benzene 1, 2 carbaldehyde. Okay. Now here in this case, when I used this compound, what happened? My main chain, I took it as this one, 6 carbon atom, that is cyclohexane. Then on cyclohexane, there is a methyl group. So this compound without CHO group is what? Methyl cyclohexane. And where is my, what about my CHO group? It is not a part of my longest chain. So I will use it as carbaldehyde. Vaishnavi, did you understand?
Yes, ma'am.
Okay, now the next one is benzaldehyde and 1, 2, and 3. So this is easy. This time I'm calling it benzaldehyde. So if I call it benzaldehyde, then I will call it 3-bromo benzaldehyde. Okay, that is one possible name. But by your method also, by taking out the CHO group also, I can call it 3-bromo benzene. If I call it 3-bromo benzene and take out the CHO group, then what will I call it? Carbaldehyde. Okay, both are correct. Both names are correct. So if you include the CHO in the longest chain, especially in case of cyclic compounds, then you call it carbaldehyde. Otherwise, you call it al. You end it in al.
Miss,
Yes, tell me.
that means the last one also can be named benzene 1, 2 benzene aldehyde, miss.
Benzene 1, 2, carbaldehyde. I told you. Which one? I've that.
That only, miss. Can't we name it benzene 1, 2 benzene aldehyde?
No, not benzene aldehyde. When you have already said benzene, then means you have not included these 2 carbon atoms, right? So then you have to make it carbaldehyde. There is no way. See, if there are 2 CHO groups, you can't write a name where you are including one CHO group and not including the other one. You have to, I will give you one example here.
I understood.
See, I had understood. See, we had done this example here, this one, you see. So you can't call it 3 carbaldehyde and 1, 2, 3 pentane dial. So all the 3 CHO groups should be treated the same way. So I took out all of them, didn't include anybody in the chain, and I made it propane 1, 2, 3 carbaldehyde. Okay, so that is how we name these compounds. Okay, now we will start with now we will start with the methods of preparation. Methods of preparation. Methods of preparation of aldehydes and ketones. So the first method of preparation, I always tell you, you must remember these 7 A's. Okay. What are the 7 A's? Let me write here. Alkanes, alkenes, alkynes, alkyl halides. If you know these 7 A's, it will be much easier. Alkyl halides, alcohols, aldehydes, and acids. These are the 7 A's. Well, how many A's? 7 A's. We are here now. Aldehydes. Right? So we have to learn a method of preparation of aldehydes from alkanes, alkenes, alkynes, alkyl halides, and alcohols, and also from acids. So when I go from top to bottom, the methods that I will use will be a type of oxidation. And from acids, when I want to prepare, then the method will be of reduction, because I'm going from bottom to top. So from here to here, what am I going to do? Reduction. And from here and here and here and here, when I want to make an aldehyde, the methods are going to be oxidation. Just keep that roughly in mind, and then you do. So let's see how. Now, first one is from alkanes. Alkanes, you know that they are not reactive, so we will leave the alkanes. First method we will learn from alkenes. How do you prepare aldehydes and ketones from alkenes? Okay. Now this reaction you have learned along with alkenes. This method is known as reductive ozonolysis. Do you remember this? Ozonolysis. This you have learned in class 11, but anyway, we will revise. Okay, now reductive ozonolysis. Ozonolysis means it has something to do with ozone. So what happens here? It is addition of ozone and followed by hydrolysis. That is ozonolysis. Addition of ozone and then breaking down the compound with the help of water. What is the reagent that we use here? As I have told you, is clear ozone, O3, H2O. And the third is zinc dust. Zinc dust, it absorbs all the oxygen, and that is why we call it reductive ozonolysis. Now, this is the reagent. You just have to remember ozone, water, and zinc dust. Now, this, it acts like a scissors, scissors. What is the meaning of scissors? In Tamil, what is scissors? Tell me. My camera has got stuck. Yes. So what is the meaning of scissors? Scissors that you use for cutting something, cutting a ribbon. So this scissors, this special scissors, what does it do? It cuts the compound at the double bond. Wherever there is a double bond, it will cut it. So let us take a compound. Alkene has a double bond. So let us take a simple first alkene, CH2 double bond CH2. What is this? This is called ethene, right? So what will we do? We will cut the alkene. How will we cut? We'll cut it here. And what will we use for cutting? You write here, O3, H2O, and zinc dust. So when you cut it here, what will happen? That it's a long drawn procedure, but we have to only understand how the product is formed, not the mechanism. So it will form two fractions, CH2 plus CH2. I've cut it here. And because of ozone, one oxygen attaches here and another oxygen attaches here. Right? So this, what we got here, the third oxygen is absorbed by zinc dust. That's why we need the zinc. So you get two compounds. What is this compound? Can you tell me? CH2 double bond O can be written as HHC double bond O. What is that? Methanol. You got an aldehyde, which is methanol. So methanol plus methanol. This is also HHC double bond O, and this is also. So you got what? Two molecules of methanol. How? By doing ozonolysis of ethene. Now let us try a few more. Now supposing I take this compound, CH3, CH double bond CH, CH3. What is the name of this compound? 2-butene. And I now again do the ozonolysis of 2-butene, O3, H2O, and zinc dust. And again I cut it here. So what will I get? I'll get two parts, CH3CH plus CH3. And wherever I have cut, right, this is double bond O, and here also double bond O. So what is this compound that I got? CH3CHO. Plus this is also CH3CHO. I got two pieces. Each piece is what? Ethanol. So what did I make? I made ethanol from 2-butene. So you can carefully choose an alkene and decide what aldehydes, what products that you will get. Now suppose it's not necessary that, supposing I have CH, I have propene. And I do ozonolysis of propene, H2O, and zinc dust. So where will I cut? Here. So how will I write? CH3CH double bond O plus CH2 double bond O. So what is this? Ethanol. You will get ethanol plus what? Methanol. So if you if you do ozonolysis of propene, you will get ethanol plus methanol. Now I want to make acetone. What do I want to make? Now I'll start with the product. So I want to make CH3 double bond O plus CH3. This is what? Acetone or propanone. This is also acetone or propanone. Now, which alkene on ozonolysis will give me this? Okay, so I want to do ozonolysis here. Ozone and H2O and zinc dust. So how will I make the alkene? I will cut out the oxygen now. So I will write here CH3, double bond, connect them with a double bond. And after drawing the structure, I should see whether I'll get the same product. Yes, I will, because I'll break it here. Where I break, I put a double bond. So ozonolysis of this compound. What is this compound? 2,3-dimethyl 2-butene. So if I do ozonolysis of this compound, I will get ketone. So depending on the ketone or aldehyde that you want as a product, you should be able to think of the alkene that will give those products. Okay, so sometimes the question is asked forward, sometimes the question is asked backward. So let us do some backward questions, like which alkene on ozonolysis will give, which alkene on ozonolysis will give acetone plus methanol. Acetone plus methanol. Okay, so how will we find out? Tell me. So I want to make what? Acetone or propanone. So CH3, C double bond O, CH3. This is one. And the other, I want to make methanol. So you write methanol like this. O, CH2 double bond O. This is methanol. So which one on ozonolysis? Which alkene? You take out this and construct the alkene CH3, double bond CH2. So what is it? 2-methyl propene. Okay, 2-methyl propene. So it's a very important, interesting question. One question could be that there is an alkene, which is an alkene, right? Forms an alkene, has the molecular formula C6H12, right? On ozonolysis, it gives an aldehyde. It gives an aldehyde and a ketone. Each with 3 carbon atoms. 3 carbon atoms. Okay, identify the alkene. Okay, so how will you do it? Identify the alkene. So there are, the alkene has C6H12, right? So that means it has 6 carbon atoms. It is breaking from the middle in such a way that it is giving one aldehyde and a ketone. So which aldehyde has 3 carbon atoms? Write that first. CH3, CH2, CH double bond O. And which ketone has 3 carbon atoms? It is the one which I have written on the top. C, CH3, CH. It will be always easy to find the product if you write it in this format. Okay, so what will I get? CH3, CH2, CH, double bond C, CH3, CH. So what is the name of this? It is 2-methyl pentene. Okay, 2-methyl 2-pentene. On ozonolysis, it will give an aldehyde and a ketone. And these aldehydes and ketone, this aldehyde and ketone, they are actually isomers of each other. Both have 3 carbon atoms each. So question can be just simple questions, appear to be a little twisted, but you can find answers for all these. Okay, so that is how you can prepare an alkene by ozonolysis. Okay. If I want to make this question an entrance level question, then what will I do? I have this compound, right? This is my compound, cyclohexene, right? And I do ozonolysis of this compound, O3, H2O, and zinc dust. What will I get? Tell me. What will I get? What will be the name of the compound that I will get? So where will it? Only 4 people are remaining. I don't know why I am taking classes. Sanjay has already left. Hariharan, are you there now, or am I teaching only Sai Kalyan and Vaishnavi?
I'm here, ma'am.
Okay. So if I cut it here, right, what will I get? A double bond here, O, and a double bond here, O. So what will be this compound? It will be 1, 2, 3, 4, 5, 6 carbon atoms. So CHO, CH2, 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 CHO. 6 carbon atom. What is this? Hexane diide. Okay. So they will say cyclohexene is subjected to ozonolysis. What is the product that I will get? So different types of product, but you should only focus at the double bond opening up and each carbon atom giving you double bond O, and you should be able to find out the product. So these are all very interesting, useful questions. If you understand the concept is properly, you will be able to answer. Now the second method of preparation, let me take it on the next page. So the second method of preparation, it is from alkynes. Okay, from alkynes. How can you prepare aldehydes and ketones from alkynes? Now this method here is known as hydration. What is the meaning of hydration? Hydration means addition of water. Hydration, it means addition of water. Addition of water. How do you do the addition of water? Just add water. Okay, and in presence of Hg2 plus and H plus. Okay, you need all these Mercury, it helps in addition of water because, you know, this is very rich. This alkynes, they are very rich in triple bonds, so it does not allow water to come near it. So mercury helps. So let us take the simple alkyne CH triple bond CH. And I add to it water first in presence of H plus and Hg2 plus. If I do that, what will happen? Water is HOH, so it will add here. So what will I get? CH2 double bond CHOH. That is the first thing. Now, normally this rearranges, but I can tell you an easy way. We let us add one more HOH in presence of H plus and Hg2 plus. So this will again add and you will get CH3CH and 2OH together. And 2OH together, what will happen? Water will be eliminated again. And if water is eliminated again, then what will you get? CH3CH double bond O. So what did I do? By addition of water, H plus and H2, Hg2 plus, I directly changed what? The alkyne into this compound which I was formed here. It rearranges and it gives you this. Okay. This is a special type of rearrangement that converts the unsaturated alcohol into an aldehyde. Okay, this compound that I got here and this compound that I got here, they are isomers. This compound being more stable, this rearranges itself into the aldehyde. So this is how you prepare aldehydes and ketones from alkynes. But here there is a small thing that you need to remember. Now instead of ethyne, if I take propyne, and I add water to it. So first I will get CH3, COH will come in the middle because of the Markovnikov's rule in presence of H plus and Hg2 plus. And this compound will now rearrange how this will go here and this will go here. So what will I get? CH3, C double bond O and CH3. So what did I get? I got a ketone. This is acetone. So ethyne gave me ethanol, but propyne gave me a ketone. So what is the rule here? The only aldehyde that you can prepare from alkynes. So from alkynes, you can only prepare one aldehyde, and that is ethanol. You can either prepare ethanol or all other aldehydes will give you only ketones. Okay, so whether I take propyne or I take butane, 1-butene, 2-butene, pentane, if I take any alkyne, I will only get a ketone. So let us take the example of, say, for example, 2-butene. This is 2-butene. And I add to it water, HOH, in presence of H plus and Hg2 plus. Just try to add and see. So what will I get? CH3C, here OH, and here double bond CH, CH3. So what will happen? This double bond will come here and this OH will go there. And what will it become? Butanone, double bond O, CH2, CH. So this becomes 2-butanone. If I take 1-butene also, I will only get 2-butanone. I cannot get an aldehyde. So the only aldehyde you can make by this method is ethanol, or only aldehyde which can be made by hydration of alkynes is ethanol. All other alkynes on hydration will give me only ketones. Did you understand the second method? So that is from alkynes. Now after alkynes, the next method that we need to learn is from third method. The third method. The third method you can say is from alcohols. We'll skip aldehyde, alkyl halides for the time being. Let us do those methods which we have already learned earlier. So from aldehyde, alcohols. Okay. So we have already learned alcohols just now. So how can you prepare from alcohols? It is always by oxidation, oxidation of alcohols. Okay, so you have learned oxidation of alcohols can be done. We can call this method also dehydrogenation. Okay, dehydrogenation, how do we bring about? With copper at 573 Kelvin. So primary alcohols, they will give aldehydes. And secondary alcohols, what will they give? Secondary alcohols,
Ketone.
ketones. They will give ketones. So you have learned this method. I need not explain in any more detail to you. I will just give you one or two examples of simple ones. Supposing I take CH3OH with copper at 573 Kelvin. This H from here and here will go. So you will get CH2 double bond O. What is that? That is methanol. And this is methanol. Supposing I take CH3, CH2OH. Again, dehydrogenation, one H from here and one from here. So what will it become? CH3, CH double bond O in presence of copper at 573 Kelvin. Ethanol will become ethanol. And the last example is of secondary alcohol. If I take CH3, CH, OH, CH3, and in presence of again copper at 573 Kelvin, what will I get? CH3, C double bond O and CH3. That is a ketone. So secondary alcohols will give ketones. Primary alcohols will give aldehydes in presence of a reagent which is a dehydrogenating agent. Okay, so dehydrogenation is also a type of oxidation. There's one more reagent that you have learned along with alcohols in great detail, that is PCC. That also can be used in the same way. PCC also oxidizes the alcohols to aldehydes and ketones. So that is the third method from aldehydes and ketones. Now one more method let's take. So we did from alcohols, from alkenes, alkynes, and now we will do a method from we have to go down to acid derivatives. So the fourth method is from nitriles. Okay, the fourth method is from nitriles. Why this? It is there. From nitriles. Okay, what are nitriles? Nitriles are compounds which have a CN group at the end of their chain. So like for example, CH3 C triple bond N. CH3CN is a nitrile. What will be it can be called methyl cyanide, which is the common name, but better we call it ethane nitrile. Ethane nitrile. So from nitrile, how do you prepare? You prepare from nitriles by hmm, so by hydrolysis, by addition of water to the nitrile. So this is cyanide or nitrile. The structure of this nitrile is CH3C triple bond N, right? If I add to it water, H2O, what will I get first? I will get CH3COH and double bond NH. We have learned this in I have told you in alkyl halides, if I take H2O and H plus, CN changes into COOH. This is one method. This is what we have learned earlier. This rearranges. So this goes here and this comes here. So what do you get? You get CH3, C double bond O and NH2. And this, if I again react it with HOH, right? It gives you CH3, C double bond O and OH. Okay. So this OH comes here and H comes here. So you get ammonia and acetic acid. So this is a method by which you can convert a cyanide into an acid, right? But this cyanide, if I reduce this cyanide, how will I reduce the cyanide? I can reduce the cyanide with SnCl2 and HCl. This is a partial reduction, So when I do a partial reduction, what will I get? Partial reduction means a triple bond will only change into a double bond. Okay, so CH double bond NH. This is known as imine, right? Now this imine, if I react it with water, what will happen? This imine will give me CH3, CH double bond O plus NH3. This is the imine. So I am giving you all possible possibilities. Cyanide, if I directly add water, I get acid. If I reduce the cyanide and then add water, I get an aldehyde. Okay, I can further reduce this imine. I can reduce it more. I can take tin and HCl, strong reduction. So it will form CH3, CH2, NH2. Then it is amine. So this is imine, this is amine. So amine and imine. And imines are the one which on hydrolysis, they will give ammonia. So this is one method which is indirectly from nitriles. Nitriles, we always talk about them because they can be easily obtained from cyanides. So this is one method of preparation from nitriles. So I leave all the extra things out. So from nitriles, how can you prepare? What are the steps? Nitrile is subjected to partial reduction. You will get amine and imine on hydrolysis will give aldehyde. Okay, so I can take any nitrile. So if I can take CH3, CH2, CN on partial reduction, which is done with SnCl2 and HCl, I will get imine, that is CH3, CH2, CH double bond NH, and that on hydrolysis with H2O and H plus, I will get CH3, CH2, CHO plus NH. Okay, so you can take any example and do. Here there is one more which is given. One more method by which it can be reduced. And that is by using a very important reducing agent, which is Dibal H. Dibal H. Okay. So what is Dibal H? What does Dibal H stand for? Dibutyl, diisobutyl aluminium. Diisobutyl aluminium. Okay, so this Dibal H is somewhat like lithium aluminium hydride or NaBH4. Lithium aluminum hydride or sodium borohydride. This is of the same category. It also reduces, but this brings about partial reduction. Partial reduction. So I can use Dibal H also for the partial reduction of cyanides. So instead of doing partial reduction with SnCl2 and HCl, I can do partial reduction here. So what can I write here? I can make a general reaction. So I can write here RCN in presence of Dibal H. Dibal H. And followed by hydrolysis, I will get RCH4. So this is a new reagent that you are learning, Dibal H. It brings about partial reduction. So from acids, if I want to make aldehydes, I can also use this reagent called Dibal H. From it can reduce esters to aldehydes, it can reduce acids to aldehydes, Dibal H. Okay, so that this is a method of preparation of aldehydes from cyanides. That is one. Now the last one for today. That is also from nitriles. The fourth
Ma'am, can you go
method
to the
of
previous slide for a minute? Okay, ma'am. Thank you.
okay. Now there is one more method of preparation from nitriles, and that is nitriles, and this time it is using Grignard reagent. Okay, so we have learned many reactions of Grignard reagent, so you will remember. So let us take a Grignard reagent, CH3MgBr. And let us take a nitrile, CH3C triple bond N. So just like when we did with aldehydes and ketones made alcohol, same way, just remember this is negative, this is positive. This is negative, this is positive. So just add positive to negative and negative to positive. So this minus will come here and this plus will come here, right? So what will I get? I will get CH3C double bond N MgBr and a CH3 here. This is the intermediate that I will get. And now I will break it down with water. Okay. So when I break it down with water, one water molecule I will write here O and H2. And the other I will write it here H and OH. So what will I get as a result of this hydrolysis? I'll get three products. First is CH3C double bond O and CH3, that is a ketone, plus NH3 plus MgOHBr. Okay, so these are the inorganic byproducts. I am not interested. I get CH3C double bond O. So I can use a Grignard reagent and cyanide to prepare a ketone. So what is the rule here? Grignard reagent plus RCN. It will always give me a ketone. Okay. And if I take Grignard reagent plus HCN, hydrocyanic acid, then I will get the aldehyde. Okay. Because you can see, just visualize here, CH3C and the next CH3 comes here. So you get a ketone. So if I want to make an aldehyde, I want to make a CHO group, then this group here should not be there. It should be HCN. So Grignard reagent plus cyanide will give me ketone, and Grignard reagent plus HCN will give me an aldehyde. Okay. So too much chemistry for today. Next method is also a little lengthy method, so I will take it up in the next class. So let me see who all are remaining. Only three of you. So Vaishnavi and Hariharan. Hariharan, did you understand?
Yes,
I
ma'am.
asked you.
Yes, ma'am.
Yeah. So can you both switch on your cameras for a moment? So Vaishnavi, are you able to see well on, you are seeing it through a phone, isn't it?
Yes, ma'am.
Are you able to manage with the phone? Is it very tiring for you? You are able to see it?
Yes, ma'am. Only for today, ma'am. Tomorrow I will use my tab.
Okay. Hariharan, in between you were not able to hear me. I was asking you a
Yes,
question.
ma'am. I had some Wi-Fi problems, ma'am.
Okay. Okay. Is it raining too much there?
Rain, ma'am.
Okay. Okay. So I'm not, I'm just closing 2 minutes early so that all have left. So there's no point in teaching a more difficult reaction. So see you tomorrow then. Okay. Bye.
Thank you, ma'am.
Thank you, ma'am. Bye.